Example 6, the velocity of a piston. Again, we're going to be using the law of cosines here. So it says, in the engine shown in figure 3.40, a 7-inch connecting rod, so we're looking at this connecting rod right here, which is drawn in that picture right there, is fastened to a crank, here's the crank right here, with a radius of 3 inches. So the radius of the crank is 3 inches. So here's your crank, there's the radius of 3 inches, okay? It says the crankshaft rotates in a counterclockwise direction. So this is going to rotate like this right here, okay? It says at a constant rate of 200 revolutions per minute. So this is what's happening. It's doing 200 revolutions per minute. It says find the velocity of the piston when theta equals pi over 3. So when this angle, remember this is moving, so that angle's obviously changing. When theta equals pi over 3, well, pi over 3 is going to be, it's almost where that picture's drawn in all honesty, but it's going in this direction. So the velocity would be measured, this would be traveling to the right. They're asking what's the velocity of it. They're asking what's x prime. They want to know the velocity, the rate of change of x would be the measure of velocity. So they want x prime. Let's think about what's given to us. What's given to us? Well, not too much is given to us. We know that one side is fixed at 7, one side is fixed at 3. Theta is given to us. We know theta is pi over 3. And then the question is, it says the crankshaft rotates counterclockwise at a constant rate of 200 revolutions per minute. So a lot of people would think that you would say theta prime here, the rate at which the angle is changing, is 200 per minute, but it's 200 revolutions. So let's think about what a revolution. A revolution is a full circle. So the angle changes by 200 times 200 full circles per minute. So what's a full circle in terms of degrees, or not degrees, radians in this case? Well, a revolution is 2 pi radians. So when they say the angle is changing, it's at theta is changing at 200 times 2 pi radians. So that would be 400 pi radians per, and then what was it? Minute is what it's in terms of. So theta prime would actually be 400 pi radians per minute is how far the angle would change. Okay, so let's look at a relationship here. We have this triangle, we have theta, we have 7, we have 3, we have x squared. So we need to look at the law of cosines. Remember, the law of cosines for our equation is, if we label the sides A, B, and C here, we know that the law of cosines is b squared equals a squared plus c squared minus 2ac cosine of theta. So let's do that in terms of r's. So b squared would be 7 squared, right? That's fixed. A squared would be 3 squared plus c squared is x squared minus 2 times a is 3 in our picture. C is x in our picture, and then cosine of theta. So let's do some math here. 7 squared would be 49. 3 squared is 9. Then we have plus x squared minus 2 times 3, so this would be minus 6x cosine of theta. I'm going to clean it up a little bit more. How about subtract 9 from both sides? When we do that, we would have 40 equals x squared minus 6x cosine of theta. Okay, so that's our equation. What do we need to do with this equation now? We need to take the derivative with respect to time of both sides of this equation. The derivative with respect to time of both sides of this equation. So what's the derivative of 40? Well, the derivative of 40 is just 0. What's the derivative of x squared? Well, that would be 2x x prime. What's the derivative of 6x cosine theta? Well, that's a product rule, right? So this would be minus 6x, the first, times the derivative of the second. Well, the derivative of cosine theta would be negative sine theta times the derivative of theta, theta prime, plus the second, which would be cosine of theta, times the derivative of the first. Well, the derivative of negative 6x would be negative 6x prime. Remember, the derivative of x here is x prime, so you got to be really, really careful with this. All right, let's see what we got here. Let's see if we can clean this up. So here we have 0 equals 2x x prime. Then we would have plus 6x sine theta theta prime. Then we would have minus 6x cosine theta. All right. So what do we have to do from here? Sorry, looking back, I said it was minus 6x cosine theta. That's not. That's a minus 6x prime cosine theta. So remember, the entire point of this is to solve for x prime. So what I'm going to do is I'm going to subtract 6x sine theta theta prime from both hand sides. So minus 6x sine theta times theta prime on both sides. When I do that, what am I left with? Well, I would have, I'm going to have to move up and do more work. So I'd have on the left, I would have minus 6x sine theta times theta prime. On the right, I would have 2x x prime minus 6x prime cosine theta. Okay. Why did I do that? Because everything on the right has an x prime. So I could go ahead and factor out the x prime. So that would be equal to x prime times what would be left in the first one would be a 2x, and then in the second one would be a minus 6 cosine theta. On the left, we still have minus 6x sine theta times theta prime. We're going to divide both sides by 2x minus 6 cosine theta. 2x minus 6 cosine theta. And on the left, we would have minus 6x sine theta times theta prime all over 2x minus 6 cosine theta, and that would equal x prime. So there it is. Wow, that's a mess. In fact, we could do some simplification. I see that we could technically factor out a negative 2 in the denominator and simplify it, but I do not friggin' care. Okay, so what do we need to know? We need to know what theta prime is. Well, that was given to us, not given to us. We were able to figure out theta prime, right? So here's theta prime. I know what that is. I don't know what x is yet. I need to solve for x. And I don't know what sine theta is yet. I need to solve for that. And I also need to figure it out for cosine of theta. Okay. So let's go back here and let's try to solve for x. Let's see if we could figure this out. We are given that, so let me find x. That's what we need to do, right? Find x. We are given that theta equals pi over 3. So let's consider that triangle when theta equals pi over 3. We know the opposite side is 7, the adjacent side is 3, and then we have x. So let's use our law of cosines equations. Again, it would be 7 squared equals, the big side equals the small side squared plus the other side squared minus twice the multiplication of the two sides, that's 2x, and then there's the cosine of pi over 3. So we got some math to do here. That's fine. We can figure this out. This would be 49 equals, well, this would be 9 plus x squared. Then this would be minus 6x times cosine of pi over 3. Remember what cosine of pi over 3 is. Cosine of pi over 3, put that into your calculator, would be 1/2. So when we have 6x times 1/2, that would actually give us 3x, right? So what do I end up with here? It looks to me like I'm ending up with a quadratic equation, aren't I? So if I subtract 49 from both sides, I would end up with x squared minus 3x, and then I have plus 9 minus 49, so that'd be minus 40 equals 0. Well, I could solve for that. Let's try factoring two numbers that multiply to be negative 40 and add to be negative 3. Wouldn't that be x minus 8, and x plus 5? Don't those work? X minus 8 and x plus 5. So the first one would give me x equals 8, and the second one would give me x equals negative 5. Well, the negative makes no sense because we're talking about the length of something here. So I was finally able to find out what x is. X is 8 in this equation. So we know what x is. Let's go back to this equation. Where x is, we would plug in an 8. Okay. So what do we have left to solve for? We need to solve for what sine theta is, and we need to solve for what cosine theta is. Well, that's not too bad because we know what theta is, right? So we also need to find sine theta and cosine of theta. But we know what theta is. Theta is pi over 3. So sine theta would be sine of pi over 3. And sine of pi over 3 is root 3 over 2. Cosine of theta would be equal to cosine of pi over 3, which would be equal to 1/2. So now I know what cosine of theta is. Cosine of theta is 1/2. I can plug that in right over here. And I know what sine of theta is. I'm trying to find a color I haven't used. How about red? I know what sine of theta is. That's root 3 over 2. So that's going to be plugged in right there. Holy cow. So what we have is x prime is equal to, will it be negative 6 times x, x was 8, times sine theta was root 3 over 2, okay, then we have times theta prime, which we determined was 400 pi, all over 2 times x, again x was 8, minus 6 times cosine of theta, and again that was 1/2. So I beg of you, please use your calculator on this problem. I don't know how you would do this without a calculator. I'm going to do a decimal approximation on this one. So please put this into your calculator, do a decimal approximation. It's not even a decimal approximation. I'm getting approximately to the nearest whole number, negative 4018. Let's think about what this is. X prime is the length here, or x is the length. So x is measured in inches, and then it's due to the time, and the time was measured in minutes. So my final answer here would be approximately 4018 inches per minute. The negative sign here just gives us direction, meaning the length of x is decreasing by 4,018 inches per minute. That is the velocity at that exact moment of time when theta equals pi over 3 for that situation. Brutal problem. Guarantee you that's not on the test. You might have one or two like that on the homework, but I guarantee you that is not on the test. Okay, I promise that's the end of the crazy examples, the really, really difficult examples I'm going to tell you. That last problem, again, would not be on the test. The one before that, probably not on the test either. This would be something more like what's on the test, and as well as the next one. So I tried to throw a couple extra examples in here that weren't super, super complicated. These examples aren't in the e-text part. They might be in the problems that you can work in, the exercises at the end of the section, but I just wanted some more examples to you to get you prepared for the test questions. So it says a bolt is pulled by a winch on a dock. The winch is 12 feet above the deck of the boat. So we can look over here. This is fixed at 12. It says the winch pulls the rope at a rate of 4 feet per second. Notice that here's the rope, so this rate is changing at 4 feet per second. It says find the speed of the boat, and again the speed of the boat is going to be the horizontal direction when the rope is 13 feet out. So it wants to know what's the speed of the boat. So I'm going to go ahead and call this side right here x, and it wants to know what x prime is, the speed of the boat. So it wants x prime, the rate of change of the boat. Okay? What's given to us? Well, a whole bunch is given to us. If we call that side x, how about I call this side y up here? We know that y is 13 at this moment in time, and we also know that the rate of change of y is also 4. Okay? So I want to look at this triangle a little better. Again, I'm calling this x, I'm calling this y, and we know this side is fixed at 12 and does not change. This forms us with a right triangle. So let's think about our equation here. We're going to use the Pythagorean theorem. Well, it's side squared plus side squared equals hypotenuse squared, so that'd be x squared plus 12 squared equals y squared. Or in this case, x squared plus 144 equals y squared. Again, we want to differentiate both sides with respect to t. And when we do that, what's the derivative of x squared? Remember, it's implicit differentiation, so that's 2x, x prime. The derivative of 144 is just 0. What's the derivative of y squared? Well, that would be 2y, y prime. Again, we're trying to solve for x prime, so why don't we go ahead and divide both sides by 2x. When we do that, we can see the 2's simplify on the right-hand side, and we'd have x prime equals y times y prime all over x. So the question is, what things do we know and what don't we know? Well, let's look at what's given to us. We know that y is 13, we could plug that in. We know that y prime is 4, so we could plug that in. So what don't we have? We don't have what x is. So we need to find x. Okay, so let's look at this triangle at this specific moment in time. The specific moment in time. We would have the left side is 12. We don't know what x is, but we do know the length of y. The length of y in this case is 13. So again, we can use the Pythagorean theorem. X squared plus, here in this case it's 12 squared, has to equal 13 squared. So that's x squared plus 144 equals 169. Subtract 144 from both sides, and you would have x squared equals, would that be 25? Then we square root both sides, and we would have x equals 5. So at the moment in time when the dock is 12 feet high, the rope is 13 feet long, we know that the x, the distance from the dock, has to be 5 feet. So what can we do with that? We can plug x equals 5 into our equation over here to solve for x prime. So let's see what we get. I'd have x prime, let me use black, would be equal to y, which is 13, times y prime, which is 4, all over x, which is 5. So let's plug that into our calculator. 13 times 4 divided by 5, hit enter, and I'm getting 10.4. Let's think about this is x, which is a distance, and that's measured in feet. With respect to time was in terms of seconds. So this would be 10.4 feet per second. So I hope that helps you out. I hope that gives you a better idea of what I'm expecting on the test. A little bit of work on that one because we had to solve for x, but other than that, a very straightforward problem. That's the level of difficulty that I'm looking at on the test for you.